Hello? Yeah, am I audible now? Okay, okay, sure. I got the confirmation from my questions. Okay, so hello, good afternoon, everyone.
Good afternoon.
Good afternoon.
Uh, I'm Ahad Shaikh, and I'm a research associate at Elite Techno Groups. And I, for today's session, we have Mr. Varun and Mr. Tamil Sevan, Assistant Professor of Mechanical Engineering from Sri Krishna Institute of Technology. So I'm really happy to announce this association for this boot camp. And on behalf of ETG, I really appreciate mentors like you that who take initiative to guide students and get the technical knowledge via sources. And we also have various students from SRIT Institute of Technology. I guess they are from mechanical and electrical background. So I greatly welcome you all for today's session. So Mr. Varun, if you have some words uh, to tell to students.
Yeah, thank you, Ahad Sheikh, for the collaboration between Sri Ramakrishna Institute of Technology
Mhm.
and ETG Technology. There's a small mistake in the college name. That's not a problem. We are from Sri Ramakrishna. You
Yeah,
introduced
yeah.
as Sri Krishna. Okay.
Yeah, Sri Ramakrishna Institute of Technology, right?
Yeah. And
Yeah.
and in the meeting, we have sent the circulation. We have sent the
Mhm.
invitation to all the second, third, and final year students of electrical and electronics engineering as well as
Great.
mechanical engineering.
Great.
Today, for institution for students, they are writing their examination, and
Okay.
afternoon is holiday for them.
Mhm.
So we are
Okay.
expecting all the 100 students are going to participate in this event. Slowly, the
Great.
count is getting increased.
Mhm.
Uh, Once again, thank ETG Technologies for giving us the opportunity and
Mhm.
sharing the knowledge on gravity battery. It's a new concept. This will be
Mhm.
much more helpful for the mechanical engineers as well as the electrical engineers. They can explore their knowledge on
Mhm.
energy storage devices as well as on the battery sector.
Yeah.
Thank you for your acceptance and in the lecture. And I thank Mr. Tamil Chelvan, who's always be with me and supporting the organizing all the students for this meeting. Thanks, Tamil. Over to you, Agat.
Yeah. Thank you. Thank you very much, Mr. Varun. So once again, welcome to all the students and faculties of SRIT Institute. So let's begin today's session. Okay. So give me a moment to present my screen. Yeah. Is my screen visible?
Yes, sir, it's visible.
Yeah. Okay. Okay. Thank you very much, Mr. Varun, for the confirmation.
Yeah.
Okay. Yeah, students. So let's start with today's session, which is on the gravity battery, basically what it is and how it works, what is the concept, and what are the things involved in, what is the background of it. So all those things we will cover in today's session, and let's get started with it. So before actually getting started, I would like to let you guys know that. I will really appreciate if you unmute yourself and try to answer the questions I will ask in between, or if you have any kind of doubts in between. So you could let me know via chat box, or you can unmute yourself and ask the questions. Okay, so that will be greatly appreciated. Let's move ahead with today's session. So firstly, we'll see what exactly we'll be covering here in this small gravity battery related session. So firstly, we will see what energy is, and what are the different energy storage systems are there. Then power plants and different energy demands, how it fluctuates at the consumer end. Then how the power plants, they have solutions to store the excess energy that they develop. And after that, we will see what exactly the gravity battery and how it helps to save the large scale electricity. Then we'll see how what is the construction of it, what are the different components of it, and how does it basically work. Then at the end, we will have some discussion with. I will try to have discussion with you guys what you learned today and what are the future scope of this technology. So I will appreciate if you take participate in that discussion. Okay? So yeah, let's get started with the first topic. So first thing is energy. So what basically energy is? So may I know, does anyone of you know what energy means? And we talk about a lot of energy here and there. And what exactly energy is?
Energy neither created to be nor destroyed.
Okay. Yes, Sanjay. So that's basically the we can say property of energy and law of conservation of energy. As being an engineer, you definitely know that it surely can neither be created nor be destroyed. From the beginning of making of universe, it's there and it's constant throughout. So yeah, that's the thing. But what exactly how could we define the energy in simple terms? So for let's say we have a mass. Mass, we can say something which has some volume and which extracts some volume inside the space. So that thing is a mass and which has some of its own weight. So what
It
energy
is
could be
the
defined as?
ability to do work.
Yeah, great thing. It's I say it's Mirza Rizwan. Yeah, right answer, Rizwan. So energy is nothing but its ability to do work. So whatever work is happening around us is it requires something which it can be done. That's only. So energy is a source that with the help of which we do some kind of work. So whatever, like I'm speaking now, I'm doing a work, and how what is making me do this is energy. So that what energy is, it is ability to do any kind of work, whether it's mechanical, electrical, some sort of chemical reaction, anything which takes place and which happens around us, all entire in the universe, it takes some amount of energy to happen. So that's energy. Okay. So for there is a fun fact that what is energy is the world's most asked question as of now. So you see how curious people are to know about what energy is. And as some of you already said, I said Sanjay Pillai mentioned that the conservation of energy. So as we discussed, it's completely constant from the beginning of universe, and it can just be converted from one form to another form. We can neither create energy and we cannot destroy the energy. Okay? So there are different types of energy in the universe. Let's say there are mechanical energy, electrical energy, chemical energy, nuclear energy, thermal energy, you might heard of. So plenty of things are there. So may I know, do you guys, apart from the names that I mentioned here, do you guys have any other sort of energy that you know?
Gravitational energy.
Yeah, gravitational energy is one thing. So you see here in this animation that energy is being converted from one form to another form. Like sun, we get a photon or heat energy, then it reaches the ocean, water gets vaporized, and they when they go high in the sky, so they get potential energy. When they come down, they get a kinetic energy. And at the generator end, they rotate the turbine blades from which we convert it into electrical energy and we supply it to wherever the application is. So that's how energy cycle works. In the entire universe, the energy remains constant at yeah. So moving ahead, so we already have like we require energy to do all sort of works, but we cannot have energy continue. I see Sabrish, you are making disturbance here and muting me. So could you please stop doing that? And if you are not here to learn, you can please leave the meet. Okay. I request to operations that there is someone named Sabri. Just dismiss him from the
Yeah, yeah,
meet.
we are looking into it.
Yeah. So yeah, I'm really sorry for the inconvenience, guys. So let's move ahead. So we know we have different sort of energies we can have, but we cannot have the constant supply of energy whenever we need. There might be fluctuation in that. So whenever we need energy, we need to have it stored somewhere. So that's why we need to have various energy storage systems. So it could be at different levels. Okay. So how we can store the energy? That's the first basic question. So energy could be at various scales. It could be of around few watts of energy, few joules of energy, a few watts of energy, then some kilowatts, megawatts, gigawatts. So it increases as the demand at the consumer rate increases. So for different energy storage system, there might be different scales. Okay. So what are different energy storage devices based on the uh, capacity that they store? What do you think? What are the different types of energy storage devices are there? In our day-to-day life, we come across various sort of
Battery,
battery. Yeah, exactly. Battery is one of them.
like it store chemical energy
Hmm.
and provides
So
us electrical energy.
one thing is battery,
Yeah,
and just there is not just battery. There are multiple things which stores energy in themselves. Yeah, Karthik is saying fuel cell. Correct.
thermal energy.
Thermal energy. Not energy, but the device which stores that energy. So do you know what the device is called that stores the thermal energy?
Insulator.
No, it does not store the energy, but it entraps or it just restricts the flow of heat. So, but it's a part of thermal batteries. There is a concept, just like gravity batteries. There is one more concept as a thermal battery, which stores the energy in the form of heat. So that also could be one thing.
Okay.
Any other devices like these are just you are mentioned battery and fuel
Capacitors.
cell. Yeah, exactly. Capacitors, ultra capacitors, super capacitors. So they also store energy, but like it depends. Each of them has their own advantages and disadvantages.
Inductors store.
Yeah, industrial at some extent it also stores the energy, but it cannot be for a very long time, and you cannot count it as a distinct
Energy.
energy storage device. Yeah.
Yeah,
So just here, I will give you a hint. There could be some mechanical energy storage devices as well.
yeah. We have flying wheel.
Not flying wheel, it's flywheel.
Yeah, sorry, flywheel.
Yeah, so flywheel is there. What flywheel does is it takes the excess energy, which is so in case of engine, in four-stroke engine, you see there is just one power stroke, and rest three of the strokes they consume the power from engine. So how that energy is provided? So one power stroke which happens, that energy is stored inside the flywheel and it rotates and it supplies which is required to for another three strokes, and it has other various applications as well. So flywheel is also one energy storage devices. Okay, so I guess you guys have idea about what are different energy storage devices as of now. So by being human, we also are some sort of energy storage devices, but we can utilize it for ourselves itself. So whatever food we eat, it gets stored in our stomach in a form of chemical, and we utilize it for our own purpose. But what these energy storage devices they do, we can utilize it for other purpose. They just store the energy and don't consume it. So that's the difference. Okay. So yeah, let's move ahead. So now we'll see what are different types of power plants are there. How we, or like basically we can say we generate powers, but basically what we do is we convert it from one form to another form. So what are different power plants are there that we come across? So there could be different ways we can generate power, but first let's see that what happens, what electricity we are consuming right now is like constantly being generated at some of the other power plant. But the demand that in cities and the commercial industrial areas is not constant at each and every point. So what happens? There are fluctuations in the demand. Okay, so you can see there in the daytime there is a less energy, like there is a more demand, and during the night time there could be less demand. But what we generate at the plants is a little different. So what we have to do is whatever excess energy the power plants are generating. Okay, so those things we have to store somewhere, so that whenever there is a less energy or when there is a high demand and the supply is less, so we can utilize that energy to provide it to the cities and the residential areas. So that thing is there. So there are different types of power plants. You might know the thermal power plant, then a nuclear power plant, and some renewable energy resources are as well there. So, what do you think? What happens inside thermal power plant basically?
They generate energy.
Yeah, but how exactly? All of them generate energy basically.
A
So,
thermal power plant generate energy from heat.
yeah, so what happens, the coal is burned there with the help of like some natural gas could also be used. So water is there, water is converted into steam. Then there are steam turbines. Okay, so steam turbines, they are made to work, and whatever their rotation, whatever electricity they generate, we get it transferred to the consumer end. So that's how thermal power plants work. Then there are
Boilers.
yeah, boilers are there. Sure.
So boilers are utilized in thermal power plants.
Yeah, so there is a like water is used to, it gets heated up, and then that it's converted into steam, and sometimes superheated steam for better efficiency, and it gets the energy which we generate, it gets supplied to the consumer. And there are nuclear power plants as well. So you might know there is a uranium.
Yeah, fusion.
Yeah, electrical, sorry, nuclear fission and nuclear fusion. So there are two terms. So what basically is done in the nuclear power plant, nuclear fission is used. They break the atom into two or three parts, uranium atom, and it creates a chain reaction which generates a high amount of heat. And that heat is utilized again to convert the water into the steam, and the same cycle goes on as it happens in the thermal power plants. But the difference is we are using here a nuclear energy, and here we are using the coal and our the fuel, basically natural gases. So nuclear power plant, they also generate some sort of let's say bad effects on the environment. They they create a radioactive material as a outcome. So that's also a thing to get disposed, which is harmful in the nature. But as compared to what emissions we get from thermal power plants, it is very less as compared to that. So that's another topic of discussion. So to overcome all these things, we have renewable energy resources. So do you guys know what renewable energy resources mean, and what are the renewable energy resources we are using now?
Wind energy and hydroelectric,
Yeah, yeah, wind energy is there,
Geothermal,
and
solar power.
hydropower plants, yeah, geothermal, exactly.
geothermal,
Yeah, geothermal
biogas.
energy. Yeah, biogas is also one of them. So there are, and one more thing, very common, I suppose you guys are missing.
Windmill.
Windmill is like already
Tidal,
there. Windmill
So
now.
solar energy.
Solar energy, exactly. Solar energy is there. So these are like renewable energy resources. When we try to generate electricity from these resources, don't generate any kind of hazardous waste or any kind of pollutant outcome. There is nothing like that. So these are the very much environmental friendly things. Okay. So let's talk some about some other thing as well. So as we are now, all the automotive industry is shifting towards the electrification. Now we are having the electric vehicles in market. So their electricity demand is surely going to increase, right? All the people, they will try to charge their vehicles which has a like lot about 150 kilowatt of capacity. So energy demand is going to increase, and to fulfill that demand, what power plants will do, the governments, they will set up more power plants to generate and to compensate for the energy demands. But if we keep generating energies or electricity from this thermal, nuclear, or the we can say conventional ways, it won't be very much effective shifting from conventional vehicles to electric vehicles. Because what happened in conventional vehicle, we used to get harmful pollution from the vehicle itself. But in EV, even we are having a zero emission solution, but the electricity which is being getting input here in a battery, it's being generated from the conventional source itself, which are generating high pollutions. So no matter if we are having a zero emission solutions, in another manner we are developing a pollution. So in order to overcome that and to avoid that situation in future, we must have to shift to renewable energy resources. Like, then only it will make sense shifting from commercial vehicles to electric, right? So, what do you guys think? Have is Are we doing good in making the renewable energy resources?
Yeah, uh, yeah, it's actually good to be
Hmm. Hmm.
environmentally free, like
Exactly,
b-
exactly. So as
having
far,
ecological balance. But we
yeah,
will be
definitely.
facing a lot of challenges, like battery depreciates its life,
Hmm.
its energy as we
Exactly.
keep. So
If it's kept idle at like its shelf life, basically what we call it as. So if it's kept idle and not being used, so it there is a self discharge in batteries.
yeah,
Yeah. So that thing is also there. So when we are shifting from one technology to another technology, there are a lot of challenges that we face. Okay. For example, if you say wind energy or solar energy, what are the concerns of having solar as a source of power?
solar. So if we are using solar,
Mm-hmm.
then we need a lot of space.
Mm-hmm. Yeah, at installation point of view, if we say
Yeah,
a lot of area is required. That's the one thing.
area. Then we need a
High speed
require.
wind are not useful for wind
Mm-hmm.
turbine.
Yeah, uh, exactly. So what is there is we cannot have uh, heat from the sunlight constantly entire day. The sunlight will be there just from morning, let's say 7 or 8, like intense sunlight, till the evening 5 to 6. But in this time only, solar cells would work. What after 6 in the evening to 6 in the morning? So this 12 hours of time we won't have the supply of energy, and but we have demand. We use electricity in this remaining 12 hours as well. What we have to do is we have to save the energy that uh, we are generating in the daytime. So that's why we also need to have the energy storage systems, right? Energy storage system, what we call it. But let's say we use like batteries. So batteries, they are like very costly, and they also have some self-discharge rate. And having a large and bulk amount of batteries, it is very difficult practically, because there are thermal issues with battery. There is a maintenance for that. So everything, the
It can't be
large amount of
portable.
energy, yeah, and they are also not portable. Energy storage device that need not to be very much portable thing when we are talking about mass scale storage. And in wind turbine also, wind is not blowing constantly 25 hours a day. So that's also a thing. So whatever energy we generate here, we have to store it somewhere. So that's how energy storage system comes in picture. So let's talk about those energy storage system at power plants or high scale energy generation is there. So how we store the energy. So let's see first thing. So the first thing that people do is battery banks, basically. So there are like for not a very fast adoption is there in terms of battery banks, but some of the power plants and some companies, they use lithium-ion batteries to store energy in a bulb. Then after that, there is a compressed air energy storage. So what happens? I will just explain briefly that whatever energy we are developing, this is an energy power plant. Okay, this is a power plant. So there is a excess energy which is coming here, which as of now, which has more demand, okay, which is not being used directly. So what we do, with the help of motor, we attach one compressor, and with the help of compressor inside the ground, we compress the air. Okay. So, and we keep it compressed. And whenever there is a more energy demand, and from energy store, energy power plant, we are not having fulfilled that demand. What we do, we release that air, which goes through the expander basically, that rotates the turbine inside it, and then we get the electricity generated. So that's how it works. We, from the energy that we develop, we utilize it to compress the air. Then that air is again released and it rotates the turbine blades, and then that's how we get that energy back. So that's one of the form of energy storage system. Then there is another thing called as flywheel energy storage system. So what happens? There are large and huge bulk size of flywheels out there. So what they do, there is a motor attached at the end. Whenever there is excess energy, with the help of motors, it is delivered to these flywheels, which rotate at very high speed, and they have very high moment of inertia. So that makes them keep rotating for a long period of time. So what happens? Electricity is supplied from the motor, and it makes the flywheel rotate. And whenever we require energy, so we convert motor acts as a generator, and that rotating energy it's then converted into electricity again. So that's how flywheel energy storage system also works. They are on a very large scale and a very big flywheels, not as what we have inside our engine. They are like very huge in size. And moving further, there is pumped hydrostatic hydroelectric storage. So what happens in this uh, power storage system is basically whatever energy we have, we with the help of pump, what we do, we have a lower reservoir here and we have an upper reservoir. So at lower reservoir, we have water stored. With the help of pump, that excess energy we have, we lift that water to a upper reservoir and it is stored there. So as the height increases, it has a potential energy stored there. And whenever we have excess energy demand, we release that water and allow it to flow through the pump. Now it acts as a generator. Earlier it was acting as a motor pump. Now it's acting as a generator. So when water flows through there, we get that energy, we convert it into electricity, and then we again supply. So that's how the from the hydropower storage works. So do you guys like? Can you guys let me know what are the flaws of having such a huge power storage devices, energy storage devices? So firstly, let's talk about batteries. What could be the issues with batteries?
Carbonization.
Carbonization. Yeah, so basically their electrodes and all such things. So there might be some at high, you can say, when we are storing at a very large scale, there might be some toxic gases released inside the battery. And along with that, batteries don't have very
Temperature of battery.
yeah, yeah, exactly. Temperature of the battery has to be maintained. As, there are lot number of batteries and high voltage batteries. So another thing is a long life or the lifespan. So batteries don't have that very long battery lives. Okay, lifespan you can say. They have around 1,000 or at the max 7 to 8,000 life cycles they can work on. And if we talk about charge discharge in terms of years, it's around at the max 8 to 10 years. So what after that? We cannot have lot of amount invested in batteries and which has to be replaced within just 8 to 10 days, 8 to 10 years. Sorry. So that's why batteries are not the best choice for the energy storage solution. Then compressed air energy storage, you might see how complex the mechanism is and how large area and investment it would require. And it's not that much efficient as compressing the air inside the earth and getting it depressed. So that is not that much efficient. And when we talk about flywheels, as it's a mechanical component, so I hope there are mechanical guys as well. So could you let me know what sort of losses we can have in this flywheel energy storage system? So basically, how it works is there is a motor. It makes the flywheel rotate, and it's keep rotating for a long time. And when we require energy, so we extract it by turning the motor into generator. So that's how it works. So what could be the losses here?
Frictional loss.
Yeah, yes, correct. Whenever there is a mechanical component, there comes the friction. So where exactly friction could be?
Cylinder walls.
Yeah, cylinder walls, we can keep them apart. That's how we can avoid them.
Like torsional force is there, right?
Hmm.
So
What?
yeah,
Yeah. So you can see there are bearings here to support the rotating element, right? So in order to avoid the mechanical friction losses, what we use is a magnetic bearing, which keep the flywheel flowing in the air. So with the help of magnetic effect, magnetic levitation. So that's how we avoid the friction and also to avoid the air resistance. So when flywheel is rotating, it might come in the surrounding air, which might reduce the motion. So what we do, we keep it in a vacuumed cylinder. So you can see there is a vacuum generator is there, which sucks the entire air and the entire inside environment of this flywheel storage is completely isolated from the air. So that's just vacuum which reduces the overall mechanical losses. But we cannot have it for a very high megawatts of energy storage. It would be just used for uh, some little amount of energy storage at some backups in the medical hospital or the military bases. All such things we can use them as a backup, but not at some power plants as well. So that's the flywheel energy storage system. So could you guys let me know what could be the problem with the hydropower plant storage? Yeah, basically it's a good idea to lift the water up when there is a
it
excess energy.
requires a lot of space,
Exactly. So
and
you. Hmm.
it requires a lot of height from where it have to fall.
Exactly. Location is the concern, basically. So
Yeah.
you have to
Maintenance
select
is critical.
yeah, Vinayak. Can you tell me again?
Maintenance is critical.
Yeah, definitely. Like there is a huge storage is there, then mechanical forms and some transformers will be there. So maintenance will be high at all the places. So what is there, as you guys mentioned, it requires a proper place to develop this kind of energy source system where you have height, naturally build heights on mountain or hilly area which has some sort of slope and where you can make a lower reservoir and where you can make upper reservoir. Then you have to put a lot of water there. And, there might be evaporation happening due to the sunlight, so that water level could reduce, which might affect the overall efficiency of the entire storage system. So there are multiple constraints with all the energy storage system that we discussed. So there are other solutions as well that you can come across to store the energy at a large scale. Okay, so let's see what are the solutions. And I think is the battery, gravity battery that we will discuss about. Okay, so gravity battery is one of the solutions to store the energy at very large scale. So you're seeing the basic funda
So
of
it's
gravity
free
vector.
falling body diagram.
Yeah,
Like
yeah,
if we are
yes.
throwing up, we gain
It
potential
will come
energy.
down. So
Yeah.
what you do when you have excess energy, as in terms of this hydropower storage, you see, when you have excess energy, you lift the water at a certain height, and when you require energy, you drop it from that height, so that you get that potential energy converted into the rotating energy of the turbine. So it's the same thing, but here they are using water, right? And maintenance of which and pumping it at a high uh, height, it's a difficult thing. So instead of water, you could use some other thing as well. So that's the concept of gravity battery basically. So there is an object that you take at certain height and you release it from there. So whatever energy you put there to take it to that particular height, you can have it back when it falls down. So that's the same thing. When you have excess energy, you make the rotor move and lift the weight up. Instead of water, there will be a heavy weight. Okay. So when it goes up, it will store the potential energy, and when you release it, it will come down and it will have a kinetic energy. So that's the funda of gravity batteries. So you see, this is one of the energy gravity battery energy storage system. So there are cranes, 6 cranes working in different axes, and these are the mechanical blocks. So you can see from the top view. These are the cement blocks, heavy cement blocks, and they are like very much heavy, around tons of weight they have. And this height is not very small. You might assume it is several like hundreds of feet basically. So there are like thousands of blocks which when there is excess energy, what they do, the cranes they lift those blocks and place it up, make a stack of it, and whenever we require excess energy, those cranes they drop it down, and wherever they are connected with, so that motor now acts as a generator and again generates the electricity. So that's the funda of gravity battery, and this is what some power plant, the energy storage developers can cross.
So
You
what is
might
the medium we use here?
so medium by what do you mean by medium?
Like this is the gravity battery. So where it is storing its
Yeah, so that's
energy?
the thing. When you take something at certain height, you you generate a potential energy there, right? So
Yeah,
the potential
that
energy itself is a medium.
no, I got that. The potential
Mhm.
energy we are generating over there. The
Mhm.
body, which type of body you're taking over there?
Yeah, so these cement blocks, basically, as you are seeing, these are the small blocks, not small, very big one basically, but there are multiple such blocks which these cranes carry at a height. So that's how we store potential energy, and whenever we require, we drop it from that height. Okay, and whatever in the same way you can see, this is a
So
block,
if we are
just
dropping
drop.
it from height,
Mhm.
it will be hitting somewhere on the ground. So
Yeah,
there should be something we
mm,
should observe that kinetic energy.
yeah, that sort of thing could also be included there, but might that its impact might be not that much as we are getting it from dropping it from the height. So that also can be considered. Sure. So
Uh,
whatever, when it's falling down, the pulley which it is attached to it rotates, and in result it generates the electricity.
it can break the object too.
No, no, they are made with very strong composite materials, and they are not just dropped as they hit the ground. They are just placed at some this kind of mechanism. Basically, as my research is there, I have seen Siemens is in collaboration with some company which generates the power plant, and with the
Can
help
you
of
come again,
Siemens,
sir?
yeah,
Siemens?
Siemens, the German company of basically electronics and all.
Yeah, they using direct cement or they are making it a composite material?
Siemens, I'm not talking about Siemens. Siemens.
Oh,
There is- So that's the thing. Okay, so let's see how what is the construction and working of this battery basically. So you now you might have already known. Yeah, so now you might already know that there is some weight, and when it is lifted up, it charges the battery. Okay, so in terms of potential energy, it stores the energy. That's how it is charged. And when you drop it down, it basically discharges and generates the electricity that can be utilized. Okay. So that's the construction. There is just motor generator, some gearing or transmission pulley mechanism is there, and there is a weight which has to be lifted up or dropped down with the help of gravity force. So that's the basic construction of and working of the gravity battery. Okay. So now let's talk about who is making this gravity battery.
So one
And
last question, sir.
yeah, please.
Sir, as this concept I have learned in some ninth or tenth on freely falling body.
Mhm.
So in freely falling body, we assume that air around us is negligible, like the force acting on the
Mhm.
body is not
Mhm.
negligible. But if you are applying it on the practical sense, then
Mhm.
air contact also affect the body's
Definitely.
kinetic energy, right?
Yeah, exactly.
So what will be the difference, the potential energy we gain and the losses we after that we get,
Yeah,
like
so it depends on at what
efficiency?
height. Yeah, so it depends on what height you are dropping it from, what is the area it's being in contact with, and so basically, these two are the major factors that will affect. And with the help of engineering, like simulations, we try to reduce the contact area and optimum height we have to select from which if we drop it down, then we will have a minimum losses to construct. Surely, whenever there is a mechanical system or any physical system, it's not idle. There must be some loss happening. So in gravity battery itself, there are losses. As you can see, there is a pulley, gearing mechanism, and all such things. So surely the losses are there. But when you talk about gigawatts of energy, so those losses are not at that much. We could consider that. Yeah. So moving ahead, who is making these gravity batteries basically? So what do you think? How apart from this concept that taking something at certain height and dropping it from there, what could be the another thing or another way we could make these batteries? Okay. So yeah.
Not able to get the question, sir.
So this is the one way we could store with the help of gravity that lifts something up, and like this is the one mechanism that we could use to make a gravity battery or utilize the gravity as a energy storage thing. So what could be another infrastructure sort of thing that we can come across to utilize the gravity as an energy storage thing? Okay, so let me answer that. No worries. So there is one startup called Gravitricity, basically. So what they are doing is they are making the gravity batteries of now, as you already know the working mechanism of it. There is a heavy load which goes down, so we generate electricity, and to store it, we have to run this generator as a motor to lift this up. When it is at the topmost position, it is completely charged, and when you drop it, it starts getting discharged. So that's the what Gravitricity is doing already. But what unique concept they have is they are not taking it to a certain height as we saw in these images. Okay, so they are not doing it, but instead of that they are making this mechanism work in a mine shaft. So you see when there is mining happens, engineers they dig down into the earth and extract the ores from there. But when the resource is like completely exhausted, those mine shafts they remain as it is. Uh, there is a large hole inside the earth. So what they are doing, they are utilizing those things. So instead of making high-tech cranes and all such things, we could directly utilize these mine shafts. Just we have to put the heavy load there and arrange some motor generator system so that we can easily drop that weight down and discharge our battery and charge our battery that way. So what do you think? How amazing is this idea? Because we are not investing in making very huge cranes and making those cement blocks. Because you see there are like hundreds and thousands of blocks stacked over each other. And making this crane and working mechanism is also requires a great engineering. So instead of doing that, if we could directly utilize what is already there, like mine shafts, so how great it will be that we are not putting a lot of manufacturing and research and development thing. They're just utilizing what is already there from the long time. So that's what the idea Gravitricity has, and that's how they are making the shut down mining shafts in utilization and converting it into the energy storage systems. And there are multiple ways it can be beneficial. By with the help of controlling the speed of dropping it, we could control the power output. So if we require very instant and quick power, we can drop it at very high speed. And we want continuous but very low power, so we could drop it slowly so that we can generate a consistent electricity. So in that way also, it's very helpful. So this is how the gravity battery and this Gravitricity startup is working, and that's the amazing idea to store the energy. So whatever excess energy is there, you won't waste it, and it can be stored in very efficient manner at very large scale. Okay. So let's have some discussion. What do you think this idea has flaws, and what would be the future of this thing? And could there be alternate solution to this? What are your take on this?
We
Like
actually
how
have
much?
many storages like
Mm-hmm.
that is saying there are many challenges. For example, the one you stated like the vents, and we already have these. We could also build this by digging out a hole in the ground. It's much better than building it up like a multi-story building. It's no point because first of all the six-sided grain is going to be very unstable. We could have much more better alternatives for that, and we already have gravity wells that can
Mm-hmm.
help us make this more feasible. So
Yeah.
it's like a more modern, futuristic adaptation of the dams, for example. But instead
Mm-hmm.
of water, we're just pumping up concrete blocks. And another risk that I think about this is that when we manufacture the concrete blocks, it produces a lot of carbon
Lot of
dioxide.
different. Exactly, exactly.
So that would only contribute to the pollution, and we're trying to make the world pollution free by using.
Like, sir, it's how it is storing the energy. Like we are calling it a battery, right?
Mm-hmm.
Like how much time it can store energy.
Yeah, for till the time you can hold that weight at the height, it will store that energy and it has no discharge rate at all. Okay, so let's say you have something, you have lifted